Hey, what's up, YouTube? I had a good question from John on Instagram, so I thought I would take that opportunity and record a little video to talk about my thoughts on the topic. The question was, are the underpinnings of the physiological underpinnings of W prime from the critical power model the same as the physiological underpinnings of the anaerobic speed reserve, my bad, from Martin Buchheit's model? And so I thought that was a really good question. I'm by no means an expert on the anaerobic speed reserve or anaerobic power reserve in the case of the cycling or other modalities that talk about power rather than speed. But I thought I would try. And if I say anything stupid, please correct me in the comments below. I'm sure I can learn a couple things. So what I want to try and do to answer that question is first explain, as I understand them, the critical power model and the anaerobic speed reserve model, and then explain why I think that they're different things. So they don't they don't have the same physiological underpinnings. So critical power model first. So we have a two parameter model with the critical power or fatigue threshold and the W prime expressed in joules being the amount of work that can be produced above the fatigue threshold, usually applicable in the time frame of a 2 to about 20-minute effort. It can go longer, it can't really go shorter, or at least the model breaks down. So this is the field of applicability of the critical power model. You've got a low anchor point in critical power, which is also the bottom of the severe intensity domain. And then you have W prime as the amount of work that can be done above that fatigue threshold. And again, we can predict time to exhaustion in that, say, 2 to about 20-minute time frame. W prime is not an anaerobic measure. It's not an anaerobic component. We know that by modulating oxygen availability, we can have a direct impact on W prime and critical power. So people usually sometimes talk about W prime as being an anaerobic capacity, but it's not. It's influenced by many things. We don't fully understand it yet, and it is influenced in part, at least, by oxygen availability. So we can't call it anaerobic. We shouldn't call it anaerobic, even if it wasn't, because everything's linked together. Phosphocreatine and oxidative metabolism are linked. Nothing's truly anaerobic, except for, let's say, distinct processes at the cellular level. But again, everything is linked. So I think anaerobic and aerobic should not be used in those contexts. So that's for the critical power side of things. Now, the anaerobic speed reserve, as I understand it, again, I'm not an expert, so please correct me if I say anything wrong or stupid. Anaerobic speed reserve is the difference in speed between, or the relationship, let's say, between the top speed, top velocity, top sprinting velocity in the case of, say, a soccer player, a rugby player, and maximum aerobic speed or power. Maximum aerobic speed being the speed at which you express maximum oxygen uptake. So in other words, VO2 max or VO2 peak. Usually determined by a step test, continuous or not, to give you your maximum aerobic speed, which is commonly used to plan different training interventions. So the anaerobic speed reserve is this difference in speed between, we'll stay with the running modality, the difference between the peak velocity, peak sprint speed, and the speed at which you express VO2 peak. One little thing here that I want to point out, first and foremost, which does not invalidate, which does not mean that the anaerobic speed reserve isn't useful, but it's important to understand that maximum aerobic speed is predicated on a given protocol to attain it, because we know that as long as you're in the severe domain, you are going to reach your VO2 peak or VO2 max. So at what speed exactly you reach that maximum oxygen uptake will depend in large part on what protocol you use. Are you using a 30-15 intermittent testing protocol? Are you using a yo-yo? Are you using something continuous? All those things are going to influence where that maximum aerobic speed manifests itself or happens. And on top of this, another issue, let's say, is that the end stage of a step test designed to express your maximum aerobic speed does not necessarily represent the step at which you're going to be expressing your maximum oxygen uptake. So those are a couple issues to keep in mind with the mass concept, maximum aerobic speed. That being said, if you always use the same protocol as an anchor point for that mass value relative to that peak sprint velocity, then you can at least use this across time. But that brings us to the difference between those two things that we talked about so far, being that the anaerobic speed reserve is an absolute speed or power difference between a high anchor point or the highest anchor point possible on the spectrum, given that it's the maximum velocity you can sprint at or the maximum power that you can express, and maximum aerobic speed or power, again, determined by a given protocol, which can be variable. But again, if you use the same protocol consistently, then at least you know that you're testing the same thing. So that's an absolute speed difference. W prime is a work quantity. It is the amount of joules that you can, in the context of critical power and W prime. W prime is the amount of work you can complete above a certain power, which is the fatigue threshold. So there's an output component, but there's also a temporal dimension to W prime, which does not exist in the anaerobic speed reserve. So they're different things. They don't represent the same thing, meaning they can't really express or represent the same physiological. They can't have the same physiological underpinnings. Well, they could. No, that's not true. They could, but in that case, they don't, because they don't represent the same thing. W prime is the amount of work you can do above your fatigue threshold, and anaerobic speed reserve is the absolute speed or power difference between peak power output or top sprinting velocity and maximum aerobic speed as defined by a given protocol. But both the anaerobic speed reserve and the critical power model can be used, should be used, that's another debate, but can be used to determine working priorities or training priorities for different athletes with different profiles. As in, if you assess those values and you determine that an athlete or a soccer player needs bigger top speed relative to where his maximum aerobic speed is, or relative to his team, or relative to the needs of his position, then you can do that. Same with a critical power W prime model, where depending on the sport or depending on the task at hand, you might want to optimize for one or the other. And in that case, knowing those values can help you determine how to orient that work. So here you have it. Those are my thoughts on W prime, or physiological underpinnings of W prime and anaerobic speed reserve. Again, I might have made some mistakes in that video, so please leave me a little comment below. Let me know what you think. If I went wrong anywhere, I'm happy to correct that. I'm happy to hear your thoughts about it. So what do you think about those two models? Do you think that they're the same or not? Why? Leave me a like. Make sure you subscribe to the channel, and I'll see you in the next video.